Great, thanks for that introduction, Aaron. Great, so this is just a quick overview of kind of quite a neat project that we've been involved with Aaron and Ulrich at Port Bailey to try and implement some of the deep learning techniques that we've been developing here at Indufor for the last year or so. Just sort of a wee bit of background, we had quite a leg up from Grant at Scion, who just cut in at the end of this presentation to kind of get us started with some of these deep learning models. And we've been working hard to try and take those learnings forward and kind of push them more into the spatial realm and try and take them operational. So with this project, basically the key aims were to develop an accurate method to track plantation survival at around age 3, provide information from that to assist foresters with stand review, and also provide information that can be used to spatially stratify the stands. So this work was undertaken over 5 forests, totaling about 500 hectares around the Otago area. So for that sort of area, wall-to-wall drone capture wasn't really feasible. While the deep learning models are pretty robust to variation in imagery sources, in order to keep the imagery consistent and to keep the capture short and sweet, aerial imagery capture was definitely the best solution. So we got some captures with Skyview, and that had a number of additional benefits. Just with the addition of a colorant for red band, which also helps separating the seedlings from any background vegetation, and also kind of a neat chance to work with some of the photogrammetric point cloud assessments to give some height information. So we also had access to an existing LiDAR surface model, so we're able to kind of difference that and start to tease out some height metrics. So this is just a quick look at what that sort of data looks like. So it was critical from the outset that our models could scale efficiency. So this imagery has a resolution of 5 centimeters. So it's quite a big data set once you scale up to 500 hectares. So here we're basically flying through one of the properties. Each detection here is rendered as an individual queryable feature with scaled by height. So this is just in a wee dashboard. So the photogrammetric point cloud was generated from the capture at about 20 points per meter and then normalized against the existing LiDAR surface model. Cool, so I just want to quickly go over how we're looking to actually share this information back with the foresters. So I'm just going to quickly change my screen. Cool. So here we have just an Arc Online dashboard interface, and this has basically all the layers that was generated from this process. And you can see we've got the aerial captures as a base map. And we can toggle on the individual tree locations. So these are all separate features. So you can see here that there is an awful lot of features. There's a very large number of detections. They each have their own metadata. But that sort of information is quite hard to pass. And so the challenge was, okay, how do we take these individual tree detections and then work it up into something which can be kind of applied operationally? And to do that, we derived a few analytical layers. Now these are basically 20 by 20 meter grids, so kind of roughly 400 square meters. And each of these contain, just by counting up the number of detections, stems per hectare. Now these averages are probably a bit lower than what the actual average would be, just because of the boundary inaccuracies. And if we turn these off again, you can see that there are rodent gaps, and while the skids have been mapped, there are other areas which aren't expected to be part of the planted area, but they're kind of dragging our averages down. But you can see that at a glance, this provides a really neat overview of where the stocking is high, or where it perhaps isn't as high. And it kind of allows a real kind of a macro overview, as well as just a good way of optimization of resource about where you really want to be focusing your attention post-planting. We also produced a similar layer that describes the detected heights of each of these tree detections within these areas. So this is also quite a useful way at a glance of comparing relative performance between areas within a stand, but still at quite a spatially granular level. And overall, this presents a really neat opportunity to derive really accurate planting maps. So this is something that Ulrich at Port Blakely has been working on, basically taking this tree location data and using that to really accurately define where the planting's taken place and where it hasn't taken place, so that the resulting mapping, which can be taken forward, is highly accurate. So just a quick word on accuracy. We looked at around 60 of these 20 by 20 meter grids and did manual tree counts. So that 60 kind of result that kind of covers about 5% of the total data set. And we were finding that with the initial runs that we've produced, we were kind of about 15% below the actual SPH. So not all the trees are being identified. The results are kind of showing that a lot of the emissions were in areas with low stocking, areas with some shadow, or areas with a high concentration of kind of thick undergrowth. So kind of pretty kind of areas to be kind of relatively expected, where it struggles a wee bit. But with a bit more development that we've done since these results were produced, and kind of harnessing more of the colour infrared, those sort of accuracy numbers can be improved. So I'm just going to quickly swap back to the presentation. Cool, so I'm just going to hand over to Pete, and he's going to go over just a few ways that we can kind of take this data forward and how it sort of fits into the overall sort of monitoring regime that follows a forest through its life.
Yeah. Well, thanks, Andrew. It's probably just worth a note, actually, the data capture was a little bit in the winter, so just around July time, so quite a lot of shadow on that. So that causes a few issues with the detection model. So yeah, subsequent captures were slightly higher sun angle, so it improved things quite a lot. But in general terms, so what we were trying to do here is sort of meet Blakely's objectives in terms of what can you get from remote sensing that could perhaps replace boots on the ground. So in that sense, can you come up with some data layers that you could give to the foresters that would improve, you know, sort of efficiency of their time, and then perhaps also move away from sort of a plot-based system to 100% census. So taking that thought a little bit further forward, can you start to understand site productivity and future productivity on that site? So really that was what it was. It was then using, and I suppose throwing ideas around, because it's a bit of a paradigm shift to go from suddenly you're sort of often managing stands at a stand level, but now you're sort of looking at a tree level. So how do you condense that information and produce something that's useful to the foresters? So I suppose just talking with Aaron and Ulrich and the team there, we're trying to sort of come up with a process that makes their workflow as efficient as possible. And it sort of also sets a baseline for the future. So I guess the point here is that if you've got a stand that's got sort of low stocking or variable growth, it's probably going to stay like that for the rest of the duration of the stand. So you've set that baseline and you've got a comparison going forward. You know, Aaron, would you want to comment at all on that?
I don't have anything to add at this stage, Pete.
Okay.
So I guess we'll just say a big thanks to you and Ulrich for sharing this data with us and letting us try and implement some of the deep learning processes that we've been developing. It's been
appreciate that opportunity. Thank you. I think that's all we've got, and might be just over to Grant. I think to carry on from here.
Thanks, Andrew and Pete. It's been great to work with you on this project, you and your team. Just handing it over now on the topic of deep learning. I'll just hand it over to Grant Pearse to give an update on where we're at with the shared data sets project. Over to you, Grant.
Thanks, Aaron. Afternoon, everyone. So for those of you that are new to the cluster group or maybe don't recall, last year Scion worked with the cluster group to shape a proposal in response to Forest Growers Research call for research ideas. And the idea that we worked on was to develop shared data sets to try and train large deep learning models and to try and get improved deep learning uptake across the industry. So what we had proposed was that we would pool data specifically from UAVs, working with Robin's Tools for Foresters group, and we would build and label the data set to try and share out some of the repetitive strain injury and deal with the COVID lockdown boredom. And then we could build these really large data sets to try and tackle some operational tasks. And the goal was to work with the cluster group members to identify these tasks and build this data set. So we put in the funding application to FGR. Unfortunately, we weren't successful, but we did have some very positive feedback from FGR, which I'd like to relay back to you all. And that was that we were the project was ranked, it was basically the first one below the line in terms of the funding that was available. So it's very much on hold and not cancelled. FGR asked us to stay in touch. Obviously, it's based on the levy, and the levy is based on the annual cut. So as the year progresses, we'll stay in touch with the FGR. And given that it was a relatively small project, we're hopeful that there could be enough to get it started this year. But we'll communicate any updates from FGR through the cluster group mailing list. And just wanted to say quickly a big thanks to all of those who did help shape that proposal. It was very much a collaborative effort. Thanks, Aaron.
Thanks very much, Grant. We've still got a little bit of time at the moment. Does anybody have any questions for Andrew or Pete or Grant?
I've got one question there. The new project does the model detect dead trees. Generally with the training, we were only looking to label live trees. And so there is that separation there. And that was also part of the accuracy assessment that we did to basically make sure that there was a class separation as well as just the spatial detection.
So the colour infrared band is pretty useful for that as well. So we haven't made probably the most use of that at the moment. So the integrated model has the RGB channels and the colour infrared running at the same time. So you kind of get a bit of both from both channels. So that's an improvement on the training data set and the output. But probably one useful comment, actually probably not reinforced here, is that you need quality data. So Andrew said that the models are quite forgiving, meaning that you can use sort of smeary data or blurry stuff. But really, if you nail the data capture and get really good quality data, so like stuff that Skyview's flying, you've really got a good start point. And then from that point, once you've got a really good area base and tree detection data set, everything else you capture in the future is so much easier.
Thanks. Any more questions?
Dave, probably here, just a comment. You were talking about how to hold that data and store it, but I think it's probably just a matter of time before you just start storing individual tree locations as a layer on the GIS, and maybe report attributes against that along the lines of how confident you are that that's a tree location. And then as you progress through the life of the stand, and you've got that as a reference, and you can use that to double check all your other remotes in the data. So if you're looking for you've got 3 peaks, but there's only 1 tree there, then that it's a triple peak tree, for example. And then if you need to remap rather than actually stick a line around a compartment for a stand, maybe what you're doing is just tagging those trees as gone now. So a different way of recording stands, but I think that's really useful information to have at that kind of level, and that the sooner we start collecting it and storing it in that form, the sooner we'll be actually able to build on that information. Because although it may not be highly useful now, I suspect once the trees are 10, 15, 20, 30 years old, that'll be really useful. So yeah, I suggest start thinking about how we store it now and tap into it. I guess the GIS is an obvious
Yeah, exactly. I mean, a lot of the research has shown that trying to separate crowns from even the highest resolution, like drone captures, can be really, really tricky. So having that per tree baseline data set where that separation is obvious at that young age makes everything easier down the line. So there is an awful lot you can do with having that per tree location data set and the ability to have separate metadata for every tree in the stand. But we're still here very much looking at the possibilities for that.
And the other point actually is, so you're picking the growth stage to get the individual tree crown. So as soon as you can do that, it's feasible to use this technology. But when you're looking at 30 centimetre high seedlings, it gets bloody hard. So that's, you obviously need a target to be able to start and to do the detections. But like you say, Dave, as you grow forward, so you get to a point where it's canopy closure, it's very hard to separate crowns once canopy closure occurs. But you can still leverage the data because you can go and get something cheaper than LiDAR, like a photogrammetric point cloud, and get the height parameter. So you're sort of on that, starting that trajectory and comparing always to a baseline. So that's really, I think, the big paradigm shift here is once we start to get to individual tree models, and some of the work with the laser scanning is sort of pointing in that in terms of quality attribution as well. You know, you can start to merge these two worlds together.
Mm-hmm.
Yeah, right.
Right. Any more questions? If not, I'll just make a quick comment myself. It's so we undertook this work in 2021, and that was the first time that we've gone down this path. We've decided to carry on and work with Indufor again this year and capture the high resolution imagery and do a project in 2022. And I think what is quite interesting is when I talked to the operational staff about the product that we'd supplied in 2021 and talked about the components of it being the high resolution imagery and also the tree detection through the deep learning algorithms, neither of those products that we provided were the staff keen to have it taken away. So, you know, it's always a challenge of the tech transfer, and if you can get something through to your staff and they see value and they don't want it taken away, then you kind of get a bit of a feel that you're on the right path. So yeah, it's just a quick comment from me